coil-over front suspension for a classic Mustang. You can spend thousands and thousands of dollars on a custom kit just like this in the aftermarket, or you can do what I did and fabricate most of these parts yourself.
Greetings, fellow DIYer, and welcome to my video.
Coil-over front suspensions have been available for classic Mustangs for a lot of years. And what's really nice about them is they are based on the original Mustang suspension geometry. This allows you to work within the confines of the Mustang and the shock tower design without having to do a bunch of cutting and modifying and changing things. Now, I'm sure some of you were thinking, wait a minute, doesn't Days Cars already have a video on his DIY coil-over front suspension? And the answer to that question is yes. Back when my YouTube channel was new and I was just getting into making videos for you, I did a video on this project, and let me tell you what, it's awful. And I don't mean that in the joking sort of way where I'm like, oh yeah, my videos aren't that good. I mean, we'll be honest, my videos aren't amazing, but I try to put out quality information, quality video with quality editing. I recently got all the parts for this project powder coated. And as I was putting the components together on the driver's side assembly, I wasn't quite sure exactly which way this bracket went. So I thought, no problem. I have all this on video. And I went back and watched the video, and to my horror, it was cringeworthy. It's super gimmicky. At the beginning of my YouTube journey, I was trying to be entertaining and funny, and frankly, I'm not either of those things. Also, the filming is horrible. I mean, come on. How expensive was a tripod? And lastly, my editing skills, poor. Just not good quality. So that video is going to be taken down. Now, it's not going to be completely taken down. I'm going to leave it up, but I'm no longer going to have it show up in YouTube searches. So people that already have the link will be able to watch it. If you really want to see that video and see just how bad it is, I hate to do this to you, but I am going to put a link down in the description, and I ask that you not click it. All right, before we get into these individual components and I discuss what it is that I have done here to create this DIY kit, let's go out to the car and take a good look at what I have going on out there. We're going to talk about why I made some of the design decisions that I made. We're going to talk about why this setup is better. And we're also going to look at some of the nice features like ease of alignment. After that, we'll come back in and I will go over these individual components and we'll look at decisions that I made, why I chose the parts that I did, and so on and so forth. So let's head into the garage and take a look at all of this installed on the car. All right, let's start at the top and work our way down. We have the mount at the top where the coil-over attaches, bolts in 4 places. Coil-over attaches, we come down, we have the upper control arm in the Shelby drop location. So we have set this up for improved camber, slightly lower car, although the Shelby drop typically only lowers the actual ride height by anywhere from 1/4 to 5/8 of an inch, depending on your configuration. Ultimately, the main reason you do it is for a better camber curve. And so we are in the lower holes. Come down, we'll move the disc brakes out of the way. We have the strut rod. We have a mount up in the pocket. You'll see that on the bench in a little bit. We'll discuss that. Comes down, we have it tied into this plate that goes underneath our main mounting bracket for the coilover. And then we have this plate so that this is in double shear. If I had just simply bolted this to this, then all the stress is on the bolt in one spot. But by having this tie-in plate, we have now put this bolt in double shear, which is way, way stronger. This is our mount for the bottom. Everything is real tight here. There's not a ton of clearance. And then we use the stock type sway bar. Obviously, this is bigger than stock. This is a 1-inch, and the end lengths that connect. The best part about this is we have eliminated the need for shims when doing an alignment. I can turn this swage tube to adjust for caster, and then under here we have an adjuster that I can turn to lengthen or shorten the lower control arm, which is going to give us our camber adjustment. Now, if all of this DIY stuff is just a little out of spec, we're not talking accuracy one side to the other. We're talking, let's say I overlooked something, or I'm having a struggle to get it aligned properly. If I really needed to, I could throw a shim or two behind the upper control arm to get everything close and then finish dialing it in with this and this. However, I don't see that as being necessary. I built in lots of adjustment to give me the ability to completely set the alignment on this car with the turn of this and the turn of this. Be lots of height adjustment with this right here, being able to tighten up these springs and get better height adjustment. The one thing you got to keep in mind is ideally for proper handling and proper Mustang suspension, you want this flat area right here as close to parallel with the road at ride height. So that does not give us tons of adjustment, although it does give us some, because it's not a hard, fast rule that it's got to be perfectly parallel. You just want it close at ride height. And this is it. This is the all powder coated, looking a whole lot better than it did in the first video, setup of my DIY coil-over front suspension. I've done a similar setup, although the design is totally different, on my 62 Galaxy. I've got a video on that as well. However, well, we'll use the word video very loosely, because when I put all that together, I wasn't shooting videos. I was just taking pictures for webpage write-ups. So that particular video is images stitched together. But still, if you have a classic Galaxy, it shows everything that I ended up having to do to put a coil-over front suspension on it as well. Now that you've seen what it looks like installed on the car, let's take a look at the individual components. Everything starts with this QA1 shock. This is 17 inches, fully extended. I believe it's got either 3.5 or 4.5 inches of travel. I bought this a long time ago, and I do not remember the exact specs on it. It's got 12 adjustments for shock stiffness, and the coil spring is a 350-pound spring. Depending on your application, what size motor you have, how light you like your suspension, you may want something different than what I chose. I chose this spring because my attitude has always been, for a performance suspension, you go with a softer spring and a stiffer shock. And with this QA1 setup, I have the ability to do that. Also, if this spring is just a little under, it's not quite what I want it to be, I can adjust the length, and that will help out significantly. Ultimately, I wanted to have a little less spring and have some adjustability than having a teeth-rattling spring that I was not going to enjoy while driving. The next most important piece in all of this is that right there. That is a screw-in ball joint. I got the ball joints and the sleeves that they screw into from AFCO. There will be a link down in the description. What's super important about these ball joints is they are not compression or retention specific. In other words, some ball joints are designed to have pressure pushing down. Other ball joints are designed to have pressure pulling out. And if you have a ball joint that is set up for one and you use it for the opposite, you run a serious risk of ball joint failure. But this U-joint is specifically designed for coil-over type suspensions and is the ball joint that most of these aftermarket kits use. And it is good in both compression and suspension. If we start at the top and work our way down, this is the cap that goes on top of the shock tower and bolts this mount in place. Now I have 4 holes here. There are 4 corresponding holes in this mount. And the shock tower itself gets sandwiched in between these 2 plates. Now, I didn't want to modify this car in such a way that would require a repair if someone wanted to go to the OEM system. So to achieve that, I made this bracket with these cutouts right here. And those cutouts allow you to fit this bracket up into the shock tower and clear the metal tabs that are designed to hold the OEM spring. This way, in the future, if someone wants to go back to stock, although I don't know why anyone would want to go back to stock, that is an option. From there, the top of the shock mounts to this, and we come all the way down to the bottom mount here on the lower control arm. Now, there are multiple pieces here. First and foremost, we have this plate right here, and it is an extra plate. It bolts up tightly to this and creates a gap right here. And what that is for double shear. So this is my strut rod, my adjustable strut rod, and it bolts right there. And by having this plate right here, we are now putting that bolt in double shear, which is going to be a whole lot stronger and a whole lot less prone to failure. This bracket is designed so that the lower mount is as close to the ball joint as I possibly could make it. The further you can get the mount to the lower control arm, the better overall handling you're going to have, because it's moving this arm down to this ball joint that gives you the best results. It gives you the best translation of road imperfections and road noise into the spring where you want it to be absorbed. And it also gives you the best leverage. So overall, that's going to give you the best result. And that's why this bracket comes as far forward as possible. Here we have the mount that takes the place of your stock strut rod. It's a nice piece of thick plate and bolts in, sandwiched underneath this mount, and gives me my mounting point for the strut rod. Now we get to the actual lower control arm itself. This was a stock replacement unit. Now I know it looks nothing like a stock replacement unit now because I modified it heavily. A lot of people have asked me why I started with a stock piece that are not known for rigidity and performance, when I could have just fabricated something from scratch. I was trying to stick within the stock configuration, and I knew that I could modify this and also strengthen it to be the best of both worlds. So the first thing I ended up doing was removing the ball joint. I then had to enlarge the hole for the sleeve. I wanted the sleeve to be more than just a welded on fit. I wanted a sleeve that was also going to be retained even if all of this welding broke. So in order to do that, I actually chucked the sleeve up in my lathe and just turned it down ever so slightly, not a lot, maybe 20 thousandths, just to create a little bit of a lip on the top. And then I was able to press the sleeve into place and weld it into place. And that's what gives me this nice mount for this screw-in ball joint. On this end, we have a female heim joint. And I ended up having to machine spacers to allow it to fit properly in the pocket. So with the heim joint, that fits perfectly up in the lower control arm pocket and gives me the space that I need. It's also machined in such a way that I can use seals on the outside of this heim joint to keep dust and debris and water and that kind of thing from getting in there. Now you may be wondering, why did I go with a female heim joint instead of a male heim joint? Every single other coil-over kit that I have ever seen like this uses a male heim joint on this end. And the problem is, it's not adjustable without disconnecting the ball joint. In other words, you can take and twist the lower control arm after the ball joint has been removed from the spindle to adjust the length. But there's no adjustment once everything is assembled. Because of the pocket that this fits in, there's no way to easily get any kind of a wrench up in there to tighten a jam nut. By going with a female heim joint, I have the ability to use this high-grade, high-strength adjuster rod to connect it to my lower control arm body. And with it being left-hand thread on one side and right on the other, if I turn it, I am effectively adjusting the length of the lower control arm, which is going to allow me to adjust camber. And then from there, I can just tighten the jam nut down and lock everything into place. Without the length of this female heim joint, I would not be able to accomplish that because this fits up into a pocket. And if you think of this as a male heim joint, the jam nut is going to end up being all the way up here, and you cannot get a wrench in to be able to tighten it down. But by going female, I was able to move it down and get it to a place where I can get a wrench on it. In order to have the best possible transition, I actually ended up notching this lower control arm after I cut it off and then bending the side tubing in so that we have a more natural transition to this sleeve and to our adjuster. I didn't want it to be a lot wider and have just a hard edge that is going to be potentially a breaking point. But by tapering everything, contouring everything to the adjuster, that gives us a much stronger piece. If we flip it over, you can see that it's all been boxed in. I have sleeves in here so that as we tighten it down, it doesn't crush this piece of steel that is boxed in the lower control arm. I've got a nice pocket for the sway bar, and then the sleeve for the screw-in ball joint was also welded in on the bottom. This should be a very strong, very flex-free lower control arm. So here we have the upper control arm, and I would love to take credit for this, but I bought this. I started this project 10, 15 years ago. My welding skills were not that good at the time. There was an aftermarket company that was willing to sell me just the upper control arm, and so I took advantage of that. If I was going to build something like this now, I would make this myself. I think I would bring the tubes all the way to the front, and then I also think I would run like a gusset here on the back just to support this a little bit. I don't think that this is a failure point. I'm not worried about this coming apart. I just like to overbuild things. I mean, clearly, this is 1/4 inch plate. This is 1/4 inch plate. I've over-engineered the entire thing. And if I was making this from scratch, I definitely think I would do that. The last piece to this puzzle is the strut rod. Now, guys that are not running a coil-over front suspension are using adjustable strut rods. And I have an entire web page dedicated to making your own adjustable strut rods for a classic Mustang running stock suspension. And if you want to have more information on the mount that goes in the strut rod pocket, that web page has tons of information on that. This is my second design specifically for the homemade strut rod project. I used a cast clevis originally, and there was some question as to its ability to stand the test of time. So then I found this steel steering link and made this mount to hold everything in place. Just like the lower control arm, where we have adjustability to adjust camber, the strut rod is also set up the same way, with a left-hand thread on one end and a right-hand thread on the other. So when we twist this swage tube, it lengthens or shortens this strut rod depending on which way we turn it. And it is that lengthening and shortening action that gives us our caster adjustment. One thing to note, all of these parts have been powder coated. One issue I ran into is something in the manufacturing process on swage tubes, or at least on the swage tubes that I'm using, did not like the heat from the powder coating. Now, powder coating gets up to between 300 and 400 degrees, not enough to, damage the metal or anything like that. But I think it took it slightly out of round. Everything seemed to tighten up and shrink up a little bit after going through the powder coating oven. Now I know what you're thinking. Well, that was just powder from the powder coating that was in the threads. The powder coater actually plugged the end of both tubes when they did the powder coating, and there was no powder coating inside the tubes whatsoever. But I still could not screw in the heim joint or the solid rod end that mounts down here. I ended up having to take a tap and running it down both ends. Now, thankfully, I had both a left hand and a right hand tap. Obviously, we got the heim joint that goes on this end so that we have perfect flexibility. It can flex and move in multiple directions on the frame mount end. And then I have a solid rod end on this end. And that gives us a solid mount. When I do alignment adjustments, I will actually loosen the bolt that mounts right here that this piece goes into so that it can pivot a little bit as I'm making the adjustment. Then once the alignment is all dialed in, I will tighten this back down, locking everything into place. So you may be wondering, why did I install this type of front suspension on my car? Aside from the obvious improvements in handling and ride quality, I needed something that would pair nicely with that. That is an independent rear suspension out of a Jaguar that has been installed in my Mustang, but that is a different video. And that's it. These are the basic components. I have not put this into production, and I'm not going to put this into production. Everything that I make and sell on my website is something that typically will fail safe. If somebody installs something here incorrectly, or for some reason we have catastrophic failure, which the way I built everything, I don't see that happening, but either way, if I was selling them, there would be a liability issue, and I am not willing to deal with said liability. If you would like information on this, if you would like measurements, I'm happy to help you out. I'm happy to give you any information that I have. I don't have drawings that I'm going to share, and I'm not willing to sell them. But if you have any other questions, please don't hesitate to contact me through my website, or go ahead and make a comment down in the comment section, and I would love to get back to you.
If you like what you've seen, please click like. If you'd like to see more, please subscribe. Thanks for watching.